Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 7 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2523. Closest prime numbers in range. Okay, so let's read the problem statement first. We have given two positive integers left and right. We have to find the two integers num1 and num2 such that num1 it should be greater than or equal to left, and my num2 it should be less than my num1, and my right it should be, so for num2, okay, see num2 here, so num2 should be less than and equal to right. Okay, we have given this right and left, so we have to find num1 and num2. So one thing is that num1 should be less than num2, and this num1 it should be greater than or equal to left, and this num2 should be less than or equal to right. Okay, both num1 and num2 are prime numbers. Okay, these two should be prime numbers, and the difference between them, num2 minus num1, is the minimum amongst all the other pairs satisfying the above conditions. Okay, difference should be minimum. All right, we have to return the positive integer array answer of nums1 and nums2. Okay, so we are going to return array of size 2. Okay, first is going to be num1 and second is going to be num2. Okay, and if there are multiple pairs satisfying these conditions, that simply means that difference is same. Okay, then we have to return the one with the smallest num1 value. Okay, so like here 11 and 13 both are prime numbers, right? Difference among them is 2, and then there is one more pair 17 and 19. Okay, among them also difference is 2, right? So in that case we have to return the pair with the smallest num1. So we are going to return this 11 and 13. Okay, return the one with the smallest num1 value, and if no such numbers exist, then we have to return -1 -1. Okay, so I hope that problem statement is clear to you guys. All right, so now see this example. Okay, so yeah, left is given as 10 and right is given as 19. Okay, so what are the different yeah, prime numbers in this range? So 10 is not a prime number, 11 is prime number, 13 is a prime number, 14, 15, 16, 17 is a prime number. Okay, 19 is a prime number. Okay, so all these are prime numbers, right? The prime numbers between 10 and 19 are 11, 13, 17 and 19. Okay, so among them difference is 2, among them difference is 4, among them difference is 2. Okay, so these two are having same difference, but we are going to return this because num1 value is smaller. Okay, the closer gap between any pair is 2, which can be achieved by 11, 13 and 17, 19. Since 11 is smaller than 17, we are going to return the first pair. Okay, so clear? Right, now see this example 2. So 4 is not a prime number, 5 is a prime number, then 6 is not a prime number. So there exists only one prime number in the given range. Okay, so the conditions cannot be satisfied, right? We have to find the difference now. So condition is not satisfied, we need at least two prime numbers in this range, right? So we are returning -1 -1. Okay, now see the constant size. Constant size is very large for this problem. Okay, so it's not like I'm not going to solve this problem using simple approach like I run one loop from 10 to 19. Okay, so my basic approach is going to be, if the constant size is very less, okay, so I'm going to run one loop from left to right 10 to 19. Okay, and in that I will call one helper method. Okay, let's say is prime one helper method. Okay, I'm going to call this, and here inside this I'm just going to pass the number. Okay, let's say I first 10, 11, 12, 13. Then I'm going to check this number whether this I, okay, number that I'm passing in this helper method is a prime number or not. So to find out whether a number is prime or not, so again I have to, inside that again I have to run one loop from 2 to less than that particular number, less than this particular I value. Okay, so I have to check the divisibility. Okay, I modulus with 2. Okay, so if anywhere this becomes equal to 0. Okay, if any number from 2 to less than I, okay, if that any number in that range divides this particular I, that simply means that it is not a prime, then I have to return false. Okay, return false, right? Because I'm checking it's prime or not. Okay, but if in case if there is no number from 2 to less than I, okay, until I -1, if there is no number in that range which divides this I completely, then in that case I have to return true. Okay, so see in this case here I'm running one loop for n times. Okay, for r minus l times. Okay, then here again I'm running one loop again and again. I'm for each number I'm running one loop in the from the range 2 to I minus 1. Okay, 2 to I minus 1. So definitely this problem is going to give us issues. Okay, we will get time limit exceed error. Okay, because size is very large. Okay, so size is very large, right? So we can't solve this problem using normal approach. Okay, using normal way to find the all the primes. Okay, so that is not possible. So how I'm going to solve this problem then? Okay, how I'm going to find out the primes? Okay, so there is one algorithm known as sieve of, let me write, sieve of Eratosthenes. Okay, Sthenes. Okay, sieve of Eratosthenes. Okay, so what does this algorithm says? Okay, so it is a very ancient algorithm which is used to find all the prime numbers up to n given limit. Okay, so let's say here up to 19 I have to find out all the prime numbers. Okay, let's say up to 19. Okay, up to 19 I have to find out all the prime numbers. So how I'm going to do that? So here let's write all the numbers 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15, then we have 16 17 18 19. Okay, so how does this algorithm works? Okay, so it does so by iteratively marking as composite not prime the multiples of each prime. Okay, starting with the first prime 2. Okay, so 1 we are not going to check, so this is a prime number, right? So 2 is a prime number, so I'm going to write 2. Okay, this is first prime number. And now what are the multiples of this 2? 2 into 2 4. So I'm going to cancel it. I'm going to cancel this. I'm going to cancel this. Okay, these are the composite numbers, right? Because all these numbers are completely divisible by 2. Okay, so I'm going to cancel out. I'm going to cancel out this. I'm going to cancel out this. Okay, now see, this is unmarked. Okay, so this is unmarked, so I'm going to mark it. Okay, so here I'm writing this 3 because 3 is a prime number. Now what are the multiples of 3? 3 into 2 6. 6 is already marked. Okay, 9, so I'm going to mark this. Okay, then 12 is already marked, then I'm going to mark 15. Okay, then 18 is already marked. Done. Okay, now after that next unmarked number is 5, so I'm going to mark this 5. Okay, 5, and I'm going to add this here in the list of prime numbers. Now 5 multiples are 10 15. Okay, all are marked. Done. Then next unmarked number is 7, so I'm going to mark this and I'm going to write it here. Now multiples of 7 are 7 14 and all are marked. Okay, now next multiple is 9. Okay, so 9 is already marked. Okay, 9 is already marked now. 11 is not marked, so I'm going to mark it 11. Okay, I'm going to write 11 here, and 11 to 12 22. Okay, so 22 is not there. Okay, so we have to stop. Okay, and then the next unmarked number is 13. I'm going to mark this 13 and I'm going to add this to my list. And 13 is multiplied 13 into 2 26, so 26 is not there. Done. Okay, so here then next is 17, so 17 I'm going to write it here, and then after that I'm going to check 34. 34 is not there. Okay, then 19. Okay, so in this way I have completely find all the prime numbers, right? Completely find all the prime numbers in just a single approach. Okay, single way. Just I'm checking one number and I'm just marking all the composite numbers. Okay, I'm closing that. Okay, so 2, and then I don't need to check 4 6 8 10 12. Okay, after 2 I'm directly checking 3. Okay, so 3 is not marked, so for 3 I am marking then 6 9 12. Okay, then again from here I don't need to check 4. Okay, I skip this, then I check the 5. Okay, then for 5 I completely mark all the numbers. So see here, 2, after 2 I'm making jump to 3, then I'm making jump to 5, then I'm making jump to 7 11 13 17 19. How many numbers I missed in between, right? There is no need to check some other numbers, right? Again and again. So in a single way I find out all the prime numbers, right? So it does so by iteratively marking as composite not prime the multiples of each prime starting with the first prime number 2. Then the multiples of a given prime are generated as a sequence of numbers starting from that prime with the constant difference between them that is equal to that prime. Okay, so this is what we need to do, right? So this is very important. Okay, Sieve of Eratosthenes. Okay, so this algorithm may be asked in interviews questions. Okay, so just make a note of this. All right, so in this way I'm going to find out all the primes. Okay, I'm going to generate one list, and once I generate all the list, then I will just check the difference between all the primes one by one, and that's it, and that will going to solve my problem. Okay, so now let's write the code. Okay, so same thing that I've explained here, I'm going to do the same thing, right? So let's move to the coding part. Let me just maximize this screen, zoom it, and now here first we have to get all the prime numbers up to the right, okay, using sieve. So here I'm going to create one array, let's name it as sieve array. Okay, sieve array. All right, and here I'm going to call one method sieve, and here I have just passed the limit, okay, until right, until this limit I have to need that. Okay, so now after that what I need, okay, so here I'm going to call this sieve. Okay, so let's define this, how I'm going to uh, get all the get the array for this sieve. Okay, so I'm going to call this method. Okay, so int return time should be array. Okay, and here just define this method sieve, and here we are passing upper limit. Okay, right is nothing but my upper limit, upper, and here limit even, right? Okay, and here inside this we have to initialize an int array to mark prime numbers. Okay, so I'm going to say that if a number is prime, if a number is prime, so I'm going to mark it as 1. Okay, and otherwise if it's not 1, if it's not 1, then it's not a prime, then it's not a prime. Okay, so I'm just going to distinguish like this. Okay, so I will set all the prime numbers as 1. Okay, whenever I find one prime number, I'm going to set it to 1. Okay, just I'm going to assign the value. Okay, so here see int array. Okay, here new int, and here upper limit plus 1. Okay, I have provided this size, and now I am going to assume all the numbers as prime initially. So arrays dot fill. Okay, so I'm going to fill all this array with 1. Okay, that simply means all the numbers are prime initially. Okay, now you know that 0 and 1 are not prime. Okay, so here sieve of 0. Okay, so 0 is not prime now, so here I'm going to set it to 0, and sieve of 1 is also not prime, this you already know. Okay, prime numbers are starting from 2, right? So I'm marking this as 1. Okay, so here what I did, right is nothing but 19 here. So until 19, okay, 1 to 19 I set all the numbers are prime. Okay, 1 to 19 all the numbers are prime. So here for 1 I assign 1, for 2 I assign 1, for 3 I assign 1, okay, 4 I assign 1, okay, at 5 I assign 1, for 6 I assign 1, 7 I assign 1. Okay, so you can treat these as indexes if you want, and 9 as 1, 10 as 1, okay, 11 as 1. Okay, now I know that 1 is not a prime number. Okay, so I'm going to mark it as 0. Okay, 0 is also not prime number, I'm going to mark it as 0. Okay, sieve of 0 and 0 1 is set to 1. Okay, 0, sieve of 1 should be 0 now. Okay, it is also not a prime number. Done. Now after that we have to iterate. Okay, for int number. Okay, so from 2 we are going to start. Okay, number 2, then here until when we have to run this. Okay, so here I have to write number into number. Okay, so it should be less than equal to upper limit, upper limit. All right, and then after that here number plus plus. All right, and here inside this we have to mark all the multiples of number as non-prime. Okay, so if sieve of number, okay, is equal to 1. Okay, so right now and 2, okay, I'm passing 2, so 2 is equal to 1, that is a prime number, right? So here now for this 2 I have to mark all the multiples of this number as non-prime. Okay, so for int multiple, it is going to start from 4, right? 2 is already marked, right? So number into number, that is going to give me 4, and here multiple, it should be less than equal to upper limit. Okay, and here after that my multiple, okay, I'm going to update it as multiple is equal to multiple plus the number. Okay, so in this way I'm just going to make a jump to that particular number. Okay, and here I'm going to set sieve of that multiple to 0 because that is also not a prime number. Okay, so the numbers which are not prime, for those numbers I'm just going to set the multiple to 0. Okay, so this is done, right? Done here. Okay, clear. Now after that, from here we have to just return sieve. Okay, so here if you see what we are doing, so 1 to 19 we have numbers. Okay, for example number 1. Okay, so initially I set all the from starting from 0 to 19. Okay, so in total we have 20 numbers, right? 0 is also there. Okay, so that is why I'm writing upper limit plus 1. Okay, plus 1, that's why. Okay, that is size. Okay, then I'm setting the array with 1 1 1 initially. Okay, so there is one array starting from 0 1 2. Okay, until this 19. Okay, I'm going to set all these to 1 1 1. Then I'm going to change it to 0, change it to 0. Okay, then I'm starting from this 2. Then we have 3 here, 4 here, 5 here, 6 here, 7 here, 8 here. Okay, that's it. 3 4 5 6 7 8. Okay, so on. Okay, so here all these are 1 1 1 1 initially, right? All this. Okay, so now what after that what I did, these are set to 0. Okay, then I'm going to start from 2. Okay, so this is 1 initially. Okay, so for this 2, what are the multiples? 4 6 8. So I'm going to update it 4 to 0, 6 to 0, 8 to 0, and so on. Okay, then after that, uh, this is done. Sieve of number is 1. Then for that particular multiple I'm going to start from 4. Okay, and multiple should be less than that. Okay, and the next time my multiple is going to be 4. Okay, initially, then 4 plus next time the number 6. So that's why for 4. Okay, then I make to jump to 6. Okay, 6 plus 2 8. Then I make to jump to this. Okay, clear? And here clear why we are using this multiple plus number, right? So I'm going to set all these to 0. Okay, then once this is done, then after that, my next time my number is going to be incremented. Okay, so next time I will check 3. Okay, 2. After that I will check 3. Okay, for 3 is this 1. So again for 3 I have to mark 6 9 and all that stuff. Okay, then same way for 5 we have to do. Okay, and we have to do until this until when my number into number. Okay, so my number is, okay, number is 2. So 2 into 2 is 4. 4 is less than equal to upper limit. Okay, 4 is less than equal to 19. Okay, next time when next time I will pick 3. Okay, so 3 is going to give 3 into 3 9 is also less than equal to 19. Okay, here inside this. Okay, 3 into 3 is okay. Then next time if I pick 4, 4 into 4 16 is also less than equal to 19. Then after that, I have to pick 5. Okay, so 5 into 5. Okay, 5 into 5 is 25. 25 is less than equal to upper limit, no, right? So until 4. So 2 3 4. Okay, so and 2 3 4 only I'm running. Okay, so now see here, here if you see 8 9. Okay, now see here now this one. Okay, so this we set to 0, this we set to 0. Okay, first time 2. Okay, so in case of 2 I marked all this 4, 4 6 8, 4 6 8 10, 12 14 16 and 18. Okay, then I run for 3. So for 3 I mark 6 6 9 and 12 and then 15. Okay, and then 18. All right, then for 4 there is no need. Okay, so until here I stop it. Okay, so here if you see now 2 3. Okay, we have 2 and 3, and now the remaining ones if you see, so here blue color pencil is not used here, right? So 7, blue color pencil is not used here, 11, and blue color pencil is not used here yet, 13, and blue color pencil is not used at 17 and 19. So see, we get the list. Okay, because we didn't change, this is 1, this is 1, and for this one it's still 1 now, right? I didn't change anything. So okay, so until 3. Okay, I am fine. Until 4 I have to check only. So 4 is already marked, so I didn't check, but until 3, okay, it is going to give us, right? So until square root of that particular number, if we find out, we will find all the list. Okay, we will update all the items which are composite. Okay, so we don't need to check for all the numbers, so until square root of that particular number. Okay, so number into number square is less than equal to upper limit. Okay, or you can say number is less than equal to square root of upper. Okay, so if I just did this now, half here half here, so number it should be less than upper root, so we will get this. Okay, we will get this, right? 2 3 and 4 we didn't check, so until here if I check, so I will get the list. Okay, operator list, right? Done. Okay, because why because after that there will not be any impact. Now if you see 5, so 10 15 20 all are marked. So after 7 14 14 all are marked. Okay, then 8 9 it's already, then 10 11 12 it crossed. Now it crossed all the number I have already crossed here. Okay, all the numbers have already crossed, right? Because from 5 all the numbers are already crossed, or we have already marked them. Okay, so there is no need. So clear until here? So this is going to give me the updated this sieve. Okay, so this ends here, and here I have to write it like here now, control V. Okay, so here this ends. Okay, this loop ends here, and then after that we have to return sieve. Okay, that's it. Okay, so now it's, this problem is very easy. Okay, so we get this all the prime numbers, okay, that we have. So now here let's create one list of integer, and here prime numbers is equal to new array list. Okay, and now we are going to store all the primes in the range left to right here. Okay, so here I am just going to check, run one loop for int num is equal to left num. Okay, it should be less than equal to right. Okay, and here num plus plus. All right, and now once this is done, so here I will just check that particular number now. So here if sieve array, okay, sieve array, okay, if I just pass this number, okay, so if it is equal to 1, that simply means that it is a prime. Okay, so here in the prime numbers list, okay, I'm just going to add what, this particular number. All right, clear? Then this is going to first step. Then next step is going to be, we have to find the closest prime pair. So here first one base condition, if this prime numbers, okay, the list that I have, okay, if prime numbers, okay, dot size, okay, dot size, all right, if it is less than 2, then in that case we have to just simply return -1, right? Return new int -1 comma -1, that's it. Okay, done. So less than 2 primes available, right? So that's why this. Now after that just we have to calculate the mean difference. Okay, so initially let's say mean difference is integer dot max value. Okay, integer dot max underscore value, and now after that closest pair we have to calculate. So here int closest pair, okay, and new int 2. Okay, and now here we are going to set initial values. Okay, so here arrays dot fill closest pair -1. Okay, and now just we have to fill all these values, right? So for int index is equal to 1, index is less than prime numbers dot size, and then index plus plus. Okay, so here inside this we have to just check the difference. Okay, so int difference okay, is equal to prime numbers dot get index, okay, minus prime numbers dot get index minus 1. Okay, so that's why I'm starting this loop from 1. All right, so here I will just check if now just 2-3 lines are pending. If difference is less than mean difference, only then we have to update na. Otherwise, why we need to update? Because we need the closest values only, right? Smallest num1 value only, okay, for the pairs having the same difference, right? All right, so here inside this I'm just going to update my mean difference as difference, okay, and here closest pair 0, closest pair of 0 is equal to prime numbers dot get index minus 1. Okay, so same way just copy this complete line, okay, and paste it here. Now closest pair of 1, okay, and I'm going to update it with prime numbers dot get index, okay, done. And then once this is done, then in the end we have to simply return the here return closest pair, okay, closest pair, okay. So now let's run the code and see if there are any code issues, okay, any spelling mistakes or anything. Let's see. So yes, so here yeah, this is the first spelling mistake. Let's fix it. Okay, this is done. Let's run it again and see there is there any other code issues. So I think here also we are using the wrong, right? So let me correct our spellings. Okay, so here this Sieve, okay, Sieve, and here I'm calling this Sieve like this. Okay, here I'm updating, creating this Sieve like this. Okay, done. Then here difference is less than mean difference. Okay, so here D capital, so let's make the D capital here. All right, let's run it again. So now what is the issue? Mean D I double F E R, oh, E is missing. Okay, I should use small variables. Okay, all right, this is done. Okay, here also same spelling mistake. Copy this, paste it here. Let's run it. All right, now what is the issue? Line, okay, here int multiple is equal to number into number, multiple is less than equal to upper limit. Let me once read it. What is the issue? Okay, here spelling mistake again. Okay, MULT, T should be here now. Let's run it again. Multiple plus equal number. Okay, so now all the test cases has been accepted finally. Okay, now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. We'll see you guys in the next video. Thank you. Bye bye.